we're going to use the Desmos graphing calculator to calculate a regression line for our table of data. So you've seen this table of data before, and I have a tab open to the Desmos graphing calculator, desmos.com/calculator. I'm going to first click in the first line. This is where I would normally type an equation, but instead I'm going to click on the plus to add a table. And I'm going to recreate this table that we're given that we've seen before. So I've got an XY table. Desmos puts subscripts. I have X sub 1, Y sub 1. But I'm going to type in my rows. So 10, 0, 11, 1. We can see Desmos is graphing the points as we enter them. 12, 2, 13, 3, 14, 4. So there are my 5 points, and it does look very linear. If you recall, this is the same table of data that we used when we were calculating first differences, and we found the first difference to be constant for this table. And so that indicated that we have a linear relationship. And if you look at our graph, it does look very linear. So now let's use linear regression. So I'm going to click in the second line, and we're going to use the equation y equals ax plus b. So instead of y, because our table has a subscript, I'm going to type y1, and Desmos automatically makes the 1 a subscript. Instead of the equal, I'm going to type a tilde. And I'm going to hit the shift key and then the key that's to the left of the 1 button. That's a tilde. Then a x1, and it creates a subscript again, plus b. And if we scroll down, here we see what Desmos has calculated. So I see my r squared is equal to 1, and my r, which is my correlation coefficient, is equal to 1. R should be between -1 and 1, and the closer it is to -1 or 1, the more linear our relationship is. Because R equals 1, our relationship is perfectly linear, and it's a positive relationship. I have a positive slope. And we've calculated that A equals 1 and B is -10. So if I fill that in, that means I have y equals 1x minus 10, or y equals x minus 10. That is the equation of the line that contains these 5 points. Okay, let's erase this. I'm going to clear out Desmos. And let's go to data that may not be quite as neat. So here we have year and average cost of 1 gallon of milk. So in 1998, a gallon of milk cost $2.65. In the year 2000, $2.89, 2002, $3, and so on. So let's look at what this data looks like. But before I do that, we could leave the years the same, but then I'd have to really be careful about my scale when graphing. Or I could let 1997 equal year 1. And with that, then 1998 would be year 1. Sorry, 1997 is year 0, so 1998 would be year 1. 2000 would be year 3. 2002 would be year 5, and so on. So this is the table that we're going to graph in Desmos. So I'm going to click on the first box and then click the plus to add a table. And let's fill in our values. So I've got, before I do that, let me move my graph over a little bit. So I've got 1, and 265, 3 and 289, 5 and $3, 7, $3.01, 9, $3.20, 11, $3.77. So there's my data, and it looks like it could be linear. It's not a perfect line like our last data was, but it looks like we could draw a line through this. So let's use linear regression and see what Desmos tells us. I'm going to type y1. It makes the 1 a subscript. I'm going to type in the tilde again, and then ax1 plus b. And Desmos calculates our regression line. Here we see r is equal to 0.9196, and that is very close to 1. So this is a very linear relationship. So it shows us that a is calculated to be 0.0934286 and b is 2.5261. Let's round these numbers to the nearest 100. So then our equation can be written as y equals 0.09x plus 2.53. And that would be considered our regression line. Let's use our regression line. So let's use this information. So we're going to use this model to predict the cost of 1 gallon of whole milk in 2024. So remember, 1997 was year 0. So for 2024, let's take 2024 and subtract 1997. And we get 27. So 2024 is the year 27. So I'm going to substitute 27 in for x in my equation. So 0.09 times 27 plus 2.53 equals 4.96. So I would predict that in the year 2024, milk will cost $4.96 a gallon.